questions. My name is Daxova. Okay, our topic for today is on matrices. What is the proper definition of a matrix? What is a matrix in simple terms? A matrix, this is just a set of elements that are arranged in order of row and column. In order of row and column. Definition of a matrix. Definition of a matrix. This is simply the arrangement of elements in order of rows and columns. So in our definition there is what we call the elements, the row, and the column. Is it okay? Okay, look at this. Here you are given a simple matrix, a matrix of A, B, C, D. So according to the definition, a matrix is the set of elements. Simply means this is your set. Your set of what? Your set of elements. So these letters that are inside are called what? Are called sets. The way entire this is called the what? Set. Set of what? Sets of elements. Sets of elements. All these are elements. Is it okay? These are elements. Now these elements are arranged in a certain order. A order of what? A order of what? A order in what? In row and in what? And in column. In row and in column. So now what is the row? What is the row? Let me come up with the definition of the row. A row of the matrix. A row of the matrix. A row of the matrix. This is just the horizontal arrangement of elements in a given set of a matrix. The horizontal arrangement in a given set of matrix. This the row of the matrix. This is the horizontal arrangement of elements in a given matrix. What about the column? The column of any given matrix. The column of any given matrix. The column of any given matrix. This is just simply the arrangement of elements in vertical axis. The arrangement of elements in vertical axis is what we call the column of any given matrix. Now let's talk about the order of any given matrix. Remember you said elements in any given matrix, they are arranged in the order of columns and rows. Is it okay? So here I'm going to say, let's say matrix A is equals to A, B, C, D. Something like this. You said any given matrix, it has the elements. Those elements are arranged in the order of rows and columns. Something like this. Simply means the order of matrix A is arranged in which one? In rows and what? Columns. Is it okay? Rows and what? And columns. What about the rows? When they say is it arranged in rows and in columns? When they say it's arranged in rows and in columns, they simply mean this column is what we call just the summation. The summation of what? The summation of numbers of columns of a given matrix. And this one is just the what? The summation of numbers of rows in a given what? In a given matrix is what we call the order. So the order of any given matrix, this is the formula, just the summation of what? Of rows by the summation of columns of any given matrix. Now let's talk about the examples. The examples of orders of any given matrix. This topic is quite simple. There is nothing like to stress. You just have to play simple, you get the important points. Okay, examples. Let's have the A, B, C, D. Here we have matrix A with different elements inside it. Okay, the order of this matrix, the order of matrix A is equals to what? The order here, remember the formula is row by what? Row by column. Row by column. The presentation of the row by column is like this. You can just say order is equals to what? Order is equals to row by column, or you can just say row by column, or you can just say row by column. You can use these different symbols just like this. So here we have row by column. How many rows are we going to get from here? How many rows do we have? We have 1, 2. Simply means I'm going to write 2. Then how many columns this side? We have 1, 2. So what's the order of this matrix? The order of this matrix is just what? 2 by 2. 2 by 2. If you want, you can just write it 2 by 2. Something like this. Just one of the same. Okay, what about this one? We all know that order is equal to what? Row by column. What are the rows? The rows these are just horizontal. So how many horizontal axes do we have here? I believe we have 2, 1, 2. So here 2 by what? By column. How many columns here? I believe we have 1, 2, 3. So here 3. What about this side? I believe here we have how many rows? We have 1, 2. So here I'm going to write 2. How many columns? Just 1. Like this. So this is your what? Your order. What about here? We have 2 rows. 1, 2. So here 2 by what? 2 by 1, 2, 3, 4, 5. By 5. You're going to get something like this. This is the order of any given matrix. Okay, from the order of matrices, now let me give you the full view of matrices. It's more like a map. Okay, let me say matrix. Here let me write matrix or a matrix. So this matrix here, we are going to say here order. We are what you call the order of any given matrix. When you come up with the order of any given matrix, I believe here in between there is what we call the operation. There is what we call the operation on what? On matrices. Operation on what? On matrices. We have 4 operations on matrices. The first one is addition of matrices. There is what we call subtraction of matrices. There is what we call multiplication of matrices, and there is what we call division of matrices or quotient of any given matrix. Even though it's not very important, it's out of the syllabus, but I'm going to show you. It's what we call division of matrices. Okay, after division of matrices, after all these things, there is another journey. There is another important journey. What is that one? This important journey is going to be. So here our next definition is what? To calculate. To calculate what? To find the inverse of any given matrix. To find the inverse of any given matrix. Now to find the inverse of any given matrix, what we are going to do? There are intermediate ones. There are intermediate things in order for you to produce a what? An inverse. Then you write here the inverse of what? The inverse of a what? A matrix. The inverse of a given matrix. So the inverse of any given matrix, there are intermediate things you have to follow. For example, here you are given an ordinary matrix. Then you write you are given an ordinary matrix here. So this ordinary matrix here you are given, you need to produce a what? You need to make a so-called an inverse. An inverse of what? An inverse of a matrix. An inverse of a matrix, you need to make an inverse of the matrix. In order for you to get this ordinary matrix, to come up with an inverse of the matrix, you are going to go through intermediate processes. I believe the first process you are going to go for is to find the what? The so-called determinant. To find the what? Determinant. To find the determinant of a matrix. When you find the determinant of a matrix, I believe you are going to do something very, very important. After finding the determinant of the matrix, you are going to guess the original matrix. When you get the original matrix here, you are going to find the so-called a cofactor. A cofactor of any given matrix. A cofactor. You are going to find a what? A cofactor. Cofactor of a matrix. Once you find the cofactor of a matrix, I believe you are going to find a so-called transpose. Transpose. Now, transpose of what? transpose of your cofactor. When you find your transpose of your cofactor, that transpose of the cofactor is what we call the adjoint. The adjoint of a matrix. The transpose of your cofactor is what we call the transpose of your cofactor is what we call the adjoint. Once you find that, I believe you are going to operate the adjoint and the determinant together in order for you to produce a what? An inverse of a given matrix. So the journey is like this. When you are given a matrix, in order for you to find the inverse, first thing that you have to do is to do what? To find the determinant. The determinant you are going to calculate, you have to keep it like this. Once you keep it, you are going to go back to your original matrix. This matrix you are going to get here, you have to find what? Its cofactor. When you find its cofactor, I believe you are going to make the transpose of the cofactor. And the transpose of any given cofactor is what we call the adjoint. That adjoint, you are going to make certain operations using what? Using determinants. When you operate your determinants on the transpose, you are going to produce a so-called what? Inverse of any given matrix. Okay, on the operation of matrices, we have four types of operations. Our first one is addition of matrices, followed by subtraction of matrices, then division of matrices, and multiplication of matrices. But for today, I'm just going to talk about three important things. I'm going to start with addition of matrices. Just you are told to find what? You are told to find A plus C, or you are told to calculate C plus A. Okay, in order for you to find the addition of A plus C, what are you going to do? You are going to do is like this. Solutions here, A plus C. First thing that you have to do is to write the matrix of A, because A is the one that is in front. So your matrix A is what? Is A, C, D, A, B, C, D. Something like this. Plus, there you are going to get what? You are going to have E, F, G, H. Something like this. Now to add matrices, what are you going to do? Excuse me. We add matrices according to their complementary partners. According to their what? Complementary partners. I believe the partner of A is E, and the partner of B is F, and the partner of C is G, and the partner of D is H. Something like this. I believe you think. Okay, this A, its partner is what? Is E, because this one is 1 by 1. 1 by 1, this is the what? This is the order of this first element. This first element is in your what? Is in your first row, and then the first column. So row by column. This is the order of this first element. And the order of element E is what? 1 by 1, because it's in the first what? Is in the first row, and in the first what? In the first column. This one is 1 by 2. Is in the first row, but in the second what? In the second column. This one is in the first row, but in the second column. I believe this is the complementary partner of this one, because they are in the same order. Those elements that are in the same order, we are going to be adding them. But those elements that are in different orders, there is nothing like to add them. Is it okay? Is it okay? Yes. Now, to add two matrices, first thing you have to follow is the order. If two given matrices, they have different orders, you can't add them. For example, you have, let's say you have matrix A to B, A, B, C, D, E, F. You have something like this. This is your F. Then to add them with K, J, I, H. These two matrices, you can't add them. These two matrices, you can't add them. Let's say this is the matrix A, this is the matrix B. You can't add matrix A and matrix B because of what? Because they are different what? Different orders. This one has the order of what? This one has the order of 2 by 3. This one has the order of what? This one has the order of 2 by 2. Is it okay? Yeah, it's okay like this. These two matrices, you can't add them because they have different what? They have different orders. You can all have matrices that are made up of what? That are of same orders. For example, this one, this is 2 by 2, and this is what? 2 by 2. Simply means these two matrices, you can do what? You can add them. So these two matrices, to add them is what? Is valid. Then you can proceed. You can just say A plus A. What are you going to get? I believe I'm going to get what? I'm going to get A plus A. Is it okay? I believe it's okay. Then B and F. You are going to get what? B, F. B plus F is not multiplication substitution. Then this one and this one are going to get what? C plus G. Then this one and this one are going to get what? D plus H. You are going to get something like this. What is the order of your answer? The order of your answer is 2 by 2. This implies is what? This implies is that you can only add two matrices of same order, and the answer you are going to have is going to have the same order as what? As the matrices you are given in order for you to do what? To add them. 2 is C plus A. Guys, to add these things is just quite simple. It's just to follow the simple laws. The first thing here in front is what? C. So you have to put matrix C where in front. What is your matrix C? I believe is E, F, G, H. You are going to have something like this. Then here add. Add what? Your A. What is your A? Your A there is what? A, B. What is your... Okay. You have C, D. You are going to have something like this. What is the order of matrix C? Is 2 by 2. What is the order of this one? 2 by 2. This one and this one, they are the same order. Simply means you can add these two matrices. And the answer you are going to get is going to have same order as these two matrices. So here you are going to say this plus this. What are you going to get? I believe I'm going to get E plus what? A. This one and this one I'm going to get F plus B. This one and this one I'm going to get G plus C. This one and this one I'm going to get H plus D. You are going to get something like this. This is your what? This is your matrix C plus A. What is the order of this matrix? The order of this matrix is 2 by 2. This is your answer here. Any question on this one? I believe no questions. Okay, now we have subtraction of matrices. Subtraction of matrices is just same as the addition of matrices. Here you are given A minus C. A minus C. What are you going to do? You are given A minus C. You have to follow the order. A is the one that is in front, then followed by what? By C. So A plus C simply means you are going to start with matrix A. Like your matrix A in front here, just A, B, then there you have to say C, D. You are going to have something like this, then minus. Minus what? Minus C. What is your C? Your C is E, F, G, H. To subtract these things, to subtract matrix A and matrix B, I believe you are going to follow the order. What is the order of this one? The order of this one is 2 by 2. What is the order of this one? Is 2 by 2. If two matrices they are of the same order, simply means you can add them and subtract them. So here, 2 by 2, I believe I can do what? I can subtract them. Now to subtract them is not just a variegated subtraction. You can't subtract your D and your E. What are you going to do? You are going to subtract them according to what? To their complementary partners. The complementary partner of A is E. The complementary partner of B is F. The complementary partner of C is G. And the complementary partner of D is H. What is the order of this first element? Is 1 by 1. What is the order of this one? 1 by 2. What is the order of this one? 2 by 1. What is the order of this one? 2 by 2. Is it okay? The order of this one? 1, 1. The order of this one? 1, 2. The order of this one? The order of this one is what? I believe is 2, 1. The order of this one is what? Is 2, 2. So here you are going to subtract 1, 1, 1, 2, 1, 2, 2, 1, 2, 1, 2, 2, 2, 2. According to what? To their complementary partners. So our answer here is going to be A minus C is equals to A minus E, A minus E, then B minus F, B minus F, then C minus G, C minus G, then D minus H, D minus H. Small letter H, D minus H. You are going to get something like this. This is your answer. Remember, the answer you are going to have is going to have same order as the what? The given matrices. What is the order of this one? Is 2 by 2. Since you have obtained 2 by 2, here you have 2 by 2, 2 by 2, simply means what you are doing is correct. If you have 2 by 2, 2 by 2, then here you produce another order which is not as same as this. Simply means what you are doing is not correct, it's incorrect. Question 2. Question 2. There question 2 we have C minus A. C minus A. What are you going to do? First thing that you have to do is to consider the flat matrix. So the flat matrix here is what? Is C. What is your C? Your C there is E, F, G, H, then minus your A. What is your A? Your A there is A, B, C, D. Okay, these two matrices, to subtract them, what are you going to do? You are just going to subtract them according to what? To their complementary partners. The partner of E is A. So here you are going to see E minus A, your first element in your C minus A. Then this minus this, what are you going to get? I believe I'm going to get F minus B. Then G minus C, I'm going to get G minus C. Then H minus D, I'm going to get H minus D. I'm going to get something like this. This is your what? This is your answer. What is the order of this one? 2 by 2. What is the order of your given matrix C? 2 by 2. What is the order of this one? 2 by 2. The answer has the same order as what? As they are given matrices. Simply means what you are doing is what? What you are doing is correct. So this is our final answer when you are going to subtract C minus A. Okay, multiplication of matrices. Multiplication of matrices. Let's say you are given matrix A, B, C, D, and C, B, A, B, and F, G, H. Now to multiply any given matrix, there is a law that we follow. We have to come up with the order of a matrix. First thing is to do what? To come up with the order of any given matrix. What is the order of matrix A? Is 2 by 2. What is the order of matrix C? Is 2 by 2 as well. Now you have seen these two numbers here. When these two numbers are similar, simply means matrix A and matrix C, you can multiply them. And the answer you are going to have is going to have the order of these two numbers here, which is 2 by 2. Okay, which is 2 by 2. So your matrix A is 2 by 2, your matrix C is 2 by 2. And the answer you are going to get is going to carry these numbers here, which is 2 by 2. Then when you have two similar numbers, it simply means those matrices, you can do what? You can multiply them. Let's say here you have let me put I, then K. You have something like this. Then to multiply these two given matrices, you are going to come up with the order. What is the order of this one? Is 2 by 2. What is the order of this one? I believe is 2 by 3. You get these two numbers here in the box, they are what? They are equal or they are similar. If these two numbers here they are equal, simply means matrix A and matrix B, you can do what? You can multiply them. And the answer you are going to have is going to have the order of 2 by 3. Is it okay? This is your what? This is your answer. To multiply matrices, we multiply what? We multiply row by column. We multiply row by column. Suppose A is equals to A, B, C, D. Then C is equals to K, I, J, L, N, O. You have something like this. What is the order of matrix A? What is the order of matrix A? The order of matrix A is 2 by 2, and the order of matrix C is 3 by 2. Is 3 by 2. The order of matrix A is 2 by 2. The order of matrix C is 3 by 2. These two numbers here, they are not what? They are not equal to each other. If these two numbers there, they are not equal to each other, simply means matrix A and matrix C, you can't multiply them. You can't what? You can't multiply them because they are what? Of different orders. To multiply matrix A and matrix B, you are going to say, what is your matrix A? What is your matrix A? Your matrix A is what? Is 2, 1, 0, -1. You are going to get something like this. Then multiplication. Multiplication of what? Multiplication of matrix what? Matrix B. Matrix B is what? 2, negative 1, negative 2, negative 3. I'm going to have something like this. Now, before you multiply these two things, what are you going to do? First thing is come up with the order. What is the order of this one? The order of this one is 2 by 2. The order of this one is what? 2 by 2. You're going to have these two numbers here. If these two numbers here they are equal, simply means this given matrix, you can multiply them. When you multiply them, the answer you are going to get, or the matrix you are going to get, is going to have the order of 2 by 2. I believe this is quite simple. Allow me to build this part. Okay, when you build this part, you are going to multiply these things. Now to multiply, what are you going to do? You are going to say row by column. Row by what? Row by column. So here you are going to say row by column. So 2 by this one, what are you going to get? 2 by 2, what are you going to get? You are going to get a 4 plus 1 by this one, you are going to get negative 2. Remember, your answer you are going to have is 2 by 2. It's going to have two rows and what? 2 columns. So this is your first what? This is your first row. This is your first column. Let me come up with another column. So you are going to say this by this. You are going to say 2 by that one is negative what? Negative 2. This by this one, you are going to have what? Negative 3. Something like this. When you reach this part, you are going to start with this one, with this one, with this, in order to fill this part and this part. So here you are going to say 0 by 2, you are going to get a what? A 0 plus. This one you are going to get positive 2. This one and this one you are going to get positive 1. Then this one you are going to get positive 3. When you come up with these values here, you are going to say this one and this one, what are you going to get? I believe I'm going to get positive 2. This one I'm going to get negative 5. This one I'm going to get a 2. This one I'm going to get a 4. I'm going to get something like this. What is the order of this one? Is 2 by 2. What is the order of this one? 2 by 2. What is the order of this one? 2 by 2. So, this is what you are going to get. This is your answer. This is your what? Your A and B, or your A and B, or the multiplication of A and B. Another example. Let's multiply matrix B and matrix C. Okay, so matrix B multiplied by matrix C. To multiply matrix B and matrix C, you are going to say, what is your matrix B? B is the one that is defined, so you have to come up with matrix B first. What is matrix B? 2 by what? 2 by negative 1. What? 2 by negative 1, negative 2, negative 3. You are going to get something like this. When you get something like this, you are going to say multiplication. Multiplication of what? Multiplication of C. What is your C? My C is just a what? 2 and 1. You're going to get something like this. When you get something like this, before you multiply those matrices, you have to come up with the order. What is the order of this matrix? Is 2 by 2. Is it okay? Yes. What is the order of this one? 1 by 2. We have one column, we have one row, we have 2 columns. So you're going to get something like this. Then you are going to do something like this. These two numbers, they are not equal to each other. If these two numbers, they are not equal to each other, simply means you can't multiply this given matrix. You can't multiply this given matrix. So here what you are going to say? You are going to say the multiplication of any given matrix with this order, it does not exist. It does not exist. Now let's come up with something that can exist. Let's say we have B. Let's change the order here. We have, let's multiply B and E. Let's try here. Let's put an E here. Okay, multiply by E. This is your B. Then what is your E? Your E there, you have something like negative 1, negative 2. This is your E. To multiply your A and your E, what are you going to do? You are going to come up with the order. What is the order of this one? Is 2 by what? By 2. What is the order of this one? 2 by 1. You are going to get something like this. What are you going to get here? You are going to get 2 by 1. This will be the order of your answer. This one and this one, they are equal. Simply means you can multiply these two given matrices. And the answer you are going to have is going to have this order. Let's drive, or let's find the BE. That is going to give us this order. You are going to say row by column, row by column. So 2 by that one, what are you going to get? 2 by this one, what are you going to get? 2 by negative 1, you are going to get negative what? Negative 2. Plus, this by this one, you are going to get what? You are going to get positive 1. This one and this one, you are going to get what? You are going to get positive 2. This by this one, you are going to get what? You are going to get this by this one, positive 2. This by this one, you are going to get positive 6. That's 6. You are going to get something like this. When you have something like this, you are going to say this one is negative what? Negative 1. This one you are going to have what? You are going to have an 8. What is the order of this one? How many rows? We have 2 rows. How many columns? We have 1. So 2 rows, then 1 column. This order is what? Row by column, which is 2 by 1. What will be the order of your answer here? 2 by 1, what is this? 2 by 1. So this is what you can do in order for you to multiply matrix A and B. Now let's talk about our pathway. Let's say you are given matrix A or just a matrix, an ordinary matrix. You are given this ordinary matrix. Then you want to produce a what? You want to make your inverse of a matrix. You want to make your inverse of any given matrix. To find the inverse of any given matrix, there is a certain pathway you have to follow. So this pathway, it has intermediate. So what are the intermediate of an inverse of a matrix? From where? From an ordinary matrix. This is the standard matrix, but this is the inverse of the matrix. You can't just move direct from a standard matrix direct what? To an inverse of a given matrix. There is a pathway you have to follow. So this pathway has the so-called intermediate. So the intermediate of this pathway is going to start with what? Is going to start with something. What is this? This is what you call the cofactor. The cofactor of a given matrix. So here you are going to say cofactor. And what you call your cofactor. So a cofactor of this given matrix, you are going to multiply this cofactor. The multiplication of this cofactor is what you call the transpose. So when you find the transpose of your cofactor, you are going to have what? When you find the cofactor, or when you find the transpose of the cofactor, you are going to make the so-called what? The hard joint. The hard joint of a matrix. So here I'm going to say transpose. So transpose of a cofactor is what we call the hard joint. The transpose of cofactor is what we call the hard joint. Now we are not going to take the hard joint direct to what? To an inverse. We are not going to do what? To take the hard joint direct what? To an inverse. So this hard joint is going to do what? Is going to associate with what? With a determinant. It's going to associate with what? With a determinant. Now, the determinant of the hard joint, or the determinant of the cofactor, or the determinant of the given matrix, or the ordinary matrix, is going to associate with the determinant of what? Of the ordinary matrix. So get the determinant of the ordinary matrix here. The determinant of the ordinary matrix here is going to operate with what? Is going to operate with the adjoint of a given matrix. So here just say the determinant in process. Determinant. So determinant of a standard matrix is going to operate with what? Is going to operate with adjoint. When the determinant operates on the adjoint, is going to give you what? The inverse of the matrix. Now, which method are you going to use? This determinant is going to operate with the adjoint as the what? The scalar. The scalar matrix. This one is going to be the scalar matrix, and this one is going to be the what? Is going to be the coefficient of what? Of the square quantity, of the scalar matrix. So here you are going to say, to find the inverse of A is equals to 1 over what? 1 over the coefficient. Coefficient, which is which one? Which is the determinant. The determinant multiplied by what? Multiplied by the adjoint. The adjoint of what? The adjoint of matrix A. The adjoint of matrix A. So this is what we call the pathway in order to produce your what? Your inverse matrix. Let's talk about the determinants. The determinant of the given matrix. Determinant of the matrix. Determinant of the matrix. To find the determinant of a matrix. To find the determinant of a matrix is quite easy according to the given matrix. For example, you are given a matrix the matrix A to be equal to what? The matrix A to be equal to A, B, C, D, something like this. Then your C, you are given something like this: A, B, C, E, F, G, H, I, J. You have something like this. Then your matrix D is A, B, C, D, E, F, G, H, I, J, K, L, N, O, P, Q. You have something like this. Okay, so the determinant of this given matrix, and the determinant of this given matrix, we are going to use different methods. Give a reason. Because the order of this one is different, the order of this one is different, and the order of this one is different. What is the order of this one? The order of this one is 2 by 2. What is the order of this one? Is 3 by 3. What is the order of this one? The order of this one is 4 by 4. So it's like this. To find the determinant of any given matrix, that matrix it has to be the what? The square matrix. What is a square matrix? A square matrix is any matrix that has the number of rows that is equal to what? To the number of columns. For example, this one. The number of rows is equal to the number of what? Of columns. Here, the number of rows is equal to the number of columns. Here, the number of rows is equal to the number of columns. So, for any given matrix, in order for you to find the determinant of any given matrix, the number of rows must be equal to the number of what? Of columns. When you start with the determinant of matrix A. This matrix A is an example of 2 by 2 matrix. It's an example of a square matrix which is 2 by 2. So to find the determinant of a what? A matrix A what? A, B, C, D. This is your what? This is your 2 by 2 matrix. To find the determinant of the 2 by 2 matrix, what are you going to do? You are going to say determinant is equals to what? Is equals to the product of what? The product of elements in what? In major diagonal. The product of elements in major diagonal minus the product of elements in what? In minor diagonal. What is your major diagonal? What is your minor diagonal? This is what we call our what? Our major diagonal, and this is what we call our what? Our minor diagonal. So to find the determinant of this given matrix, just say the product of the major diagonal minus the product of the minor diagonal. Let's say our A is equals to 1, 2, 3, 4. You have something like this. What is the determinant of matrix A? The determinant of matrix A, you are going to say determinant is equals to what? Is equals to the product of my major diagonal, which is what? 1 by 4. Then minus the product of my minor diagonal, which is what? 2 by 3. You are going to have something like this. Then here you are going to say this by this one, what are you going to get? I believe you are going to get a 4. This one, are going to get the what? A 6 minus. What are you going to get here? Negative 2. This is your what? This is your answer. So to find the determinant of 2 by 2 matrix, this is what we have to do. It's just quite simple. Just get the product of your major diagonal minus the product of your minor diagonal. Determinant of what? Determinant of a 3 by 3 matrix. The determinant of a 3 by 3 matrix. So the determinant of a 3 by 3 matrix, what are you going to do? Here we are going to use two methods. There is quite simple method and the complex method. Let me start with the quite simple method. Let's say you are given matrix A to be equal to A, B, C, D, E, F, G, H, I. You have something like this. To find the determinant of this given matrix, what are you going to do? You are just going to say, since I've been given this, ask yourself, what's the order of this matrix? Is 3 by 3. Is a 3 by 3 matrix an example of a square matrix? Yes. If it says, simply means you can find the determinant of what? Of this given matrix. Now to find the determinant of this given matrix, what are you going to do? You are going to say, okay, the determinant of this one, I'm going to say A, B, C, D, E, F, G, H, I. You have something like this. Now what are you going to do? You are going to introduce a vertical line like this. When you introduce a vertical line like this, what are you going to do? You are going to consider your first column and your second column. Just copy and paste your first column here. Then followed by what? Copy and paste the what? Copy and paste your second column. What is our first column here? Our first column here is A, D, G. What is our second column? Is B, E, H. B, E, H. You are going to have something like this. When you do something like this, this is your end of your work, this is your end of your job. Now what are you going to do? Here you are going to produce horizontal lines. Those horizontal lines you are going to name them what? For major and minor what? And minor diagonals. Let me start from here. You have to start from this point. You've seen here, this is your starting point and this is your starting point. This is your ending point and this is your ending point. What is the name of this formula? This is what you call the mask formula. You are going to produce a mask with height. Is it okay? Let me show you. Here you are going to start with dotted like this, dotted line like this, dotted line like this, another dotted line like this. I believe you have observed. Here you are going to show hellos like this. And here you are going to come up with what? With another dotted line like this, another dotted line like this, another dotted line like this. I'm going to do it like this. Okay, I believe there are two elements that are not included in masking up. You've seen this one and you've seen this one. Yes, this one is your high and this one is your high. This is your mask. So this is what we call the mask formula to find the determinant of a 3x3 matrix. Now, when you are given a 2x2 matrix, you are going to have something like this. You're going to have something like this. When you have something like this, what do we call this? This is your minor. What do we call this? This is your major. This is your major diagonal. So minor diagonal, major diagonal. If you have observed, here are lines that are going like this. How many lines? 3 diagonal lines. 1, 2, 3. What is the name of these lines? I'm going to call them what? My minor diagonal lines. These are my minor diagonal lines. And these lines that are going this side, they are called what? Major diagonal. So here, if you have observed, your lines that are going like this, these are called what? Major diagonal lines. These are major diagonal lines. So to find the determinant of a 2x2 matrix, here you are going to say the product of what? The product of your what? The product of your what? The product of your major diagonal. So the determinant of that one is what? Your product of your what? Your major diagonal minus product of your what? Your minor diagonal. Same applies to here. You are going to do what? You are going to find the product of this major diagonal. Answer you are going to keep it here. Let me say x. This is your answer. Then the product of another major diagonal, let me put it what? The product of another major diagonal, let me put it what? Z. Is it okay like this? Yes. Then you are going to say the product of this minor diagonal, let me put capital letter B or capital letter A. The product of the second minor diagonal, let me put B. The product of the third minor diagonal, let me put capital letter C. You've seen those things? Now what are you going to do? To find the determinant of that one, just say determinant is equals to what? The product of what? The product of your major diagonal x plus the product of your major diagonal y plus the product of your major diagonal z. So they are just like what? X plus y plus z. In brackets like this. Then minus the summation of products of minor diagonal lines. So this is your first minor diagonal line, which is what? Which is your A plus your second minor diagonal line, which is your what? Your B plus your third minor diagonal, which is your what? Your C. You're going to have something like this. When you have something like this is just the summation. When you come up with your summation here, let's say the answer you're going to have here, the summation of these numbers is what? Maybe it's a Q. And then the summation of these numbers here, maybe it's a W. Is it okay? So here it's a Q, the summation of this is a W. Then just a minus. Your minus of these numbers here, maybe you are going to produce capital letter P. This is your determinant.